In this video, we're going to talk about a property called differentiability. And here's the definition. If the derivative of the function f is defined at c, then f is said to be differentiable at c. So what we're going to look at is different ways in which a function can fail to be differentiable. And if it's not differentiable, we call it non-differentiable at that point. So the first way that a function can fail to be differentiable is if there is a place where the function is not defined. For instance, in this function, there's a gap at x equals 2. So if the function is differentiable, that means the derivative exists there. That means you can draw a tangent line there. Well, since that point is not even on the graph, you can't draw a tangent line, and so there is no slope at that point. There's no derivative at that point. But we can actually extend this to all discontinuities. This is a point discontinuity. At any point discontinuity, the function is going to be non-differentiable. Even if we, say, added a point in up here, you couldn't draw a tangent line through this point that would really indicate what a tangent line is supposed to indicate, the direction of the graph at that point. Also, if you have something like a vertical asymptote, that's a discontinuity. The function probably doesn't even exist at this point, and it is not differentiable. You could not draw a tangent line there. More on that later. Also, if you have a jump discontinuity, something like this, let's call that point C. The x-coordinate C. So if you tried to draw a tangent line there, well, remember how we drew the tangent line? We picked a point here and then maybe picked a point off to the side and then let that point go toward x equals c. Well, in that case, you're going to get a tangent line that looks kind of like that. But if you do it from the other side, notice that the tangent lines, so you pick a point up on the right side of c, so up on this part of the graph, as this point moves, as the x-coordinate of this point moves toward c, what's going to happen is that this secant line is going to become more and more vertical, and it's not going to match this secant line. And so the derivative, remember, is the slope of those, is the limit of the slope of the secant lines, and if that limit doesn't exist, then the derivative doesn't exist. Alright, so let's go down here to my second drawing. Here, it may not be clear what is going on here. My intention was to indicate a graph that has a vertical tangent line. If the graph has a derivative here, the derivative would be equal to the slope of that tangent line. But you may remember, in fact I hope you do remember, you ought to remember, that the slope of a vertical line does not exist. It is undefined. And so that means that the derivative is undefined at that point. So going back to these this vertical asymptote, even if the function is defined where this asymptote is, as we pick points where the x-coordinate gets closer and closer to this value of c, the slope is getting closer and closer to being, well, the tangent line, the secant lines are getting closer and closer to being vertical, and so they're at the limit the slope would not exist. And then finally we have a graph with a corner, a sharp corner, also known as a cusp. A graph with a cusp is not differentiable at that cusp. If you tried to draw a tangent line here that, again, indicates the direction, the slope of the graph there, you couldn't really do a good job of it. From this side, it looks like the slope of the tangent line is maybe headed, well, the tangent lines or the secant lines are headed to a tangent line like that, and over here, maybe kind of like that. And so you get two different values for the slope depending on whether you come from the left or the right. Since you get two different values, and what we're really talking about is a limit, then that limit doesn't exist, so the derivative doesn't exist. So to sum up, there are three different places, three different kinds of places where a function can be non-differentiable, or where a function is not differentiable. That's at a discontinuity, which I've spelled incorrectly. There I go. A discontinuity. Where there's a vertical tangent line. And where there's a cusp. And remember, a cusp is just a sharp corner.